inclined plane where we have a block of 20 kg over here and 15 kg over here. Once again, all the surface they are frictionless, pulleys they are massless, springs they are ideal, that is massless, inextensible. In this case, we are asked to suppose find acceleration or tension in the string. Let's see how we go about it. Over here, one of the mistakes that generally the students they do is, they say that if this mass is heavier than this mass, so this will go down. In one of the earlier lectures, we have done block on an inclined plane where the components of forces we have to take into consideration. So over here, when students they say that is this is 20 kg, this is 15 kg, this is heavier, this will go down. No, first you have to check it. What are the forces which are acting on these blocks? We know that is mg 200 Newton will be acting this way, taking g as, once again we are taking g as 10 meter per second square for the ease of calculation. So this will have two components, one is this way, the other is this way. The angle between these two lines is 30 degree. The same will be an angle between their perpendiculars. The perpendicular to this line is this line, and perpendicular to this line is this line. So this angle will also be theta. So this angle will also be 30 degree. What so is the angle between these two lines? The same angle will be between their perpendiculars. This perpendicular to this line perpendicular to this line. So this angle is 30 degree. So mg is 200 Newton will have two components, that is 200 cos 30 will be this component and 200 sin 30 will be this component. Either you can draw the resultant force or you can draw the components. We have broken this force into components, so this force goes off. This force is being represented by its components of 200 cos 30 and 200 sin 30. Now this block, whatsoever is the motion, it is obviously this block is going this way. So whatsoever is the force this is going to apply on this block, then there is going to be normal reaction which is going to be applied by this inclined plane, and as a result this block will not be moving along this axis. There the forces will balance. So let's focus our attention purely, that is what is happening purely along the string, what is happening. So this force is balanced by this force, so I remove it for a time being, because that is not going to contribute anything towards the motion along the string. Motion is this way, these forces are perpendicular to this motion, so as it is the component of these forces along this axis is going to be equal to 0, so that's why I have removed it for a time being. And over here it is 150 Newton, m into g. This is vertically hanging, there is no component, it's all the force. Earth is going to pull it with its all the might, that is 150, the whole weight is going to be used to pull it downwards. 15 into g, 150 Newton. Now if we look at the diagram, we see that this side is being pulled by 150 Newton, whereas this side 200 sin 30, sin 30 is half, sin 30 degree is equal to half, so 200 into half, that is it makes only 100 Newton. So mass is more, but because this is on inclined plane, this component comes out to be only 100 Newton, whereas this is 150 Newton. So this is the one thing to be seen is that at first you can just make the components etc, and before going let's say into writing equations, you can just find out that which way the system will move. So equation for this, and we can make equation for this. So this is T, one string. We know this side is heavier, 150 Newton is being applied this way, 100 Newton is being applied this way, so obviously this will go down. So equation is going to be 150 Newton minus T upwards. It is accelerating this way and this will accelerating this way with the same acceleration. Both the blocks connected by an inextensible string, so whatsoever is the acceleration of this, the same acceleration will be of this in this direction. So 150 minus T is the net force, is equal to mass is 15 into acceleration. For this it is going to be T minus 100 Newton. T is this way, 100 Newton is this way, accelerating this way, so this force is greater than this force. So T minus 100 is equal to mass is 20 into A. You can add this, 150 minus 100 is 50 Newton, minus T and plus T will get cancelled, is equal to 35 into A, and you can put the value over here to get the value of tension. Otherwise also what you could have done is, you could have taken these two blocks as a single body, as single free body. So now this circle, it has not cut this string, it has not cut the string, so this tension, it becomes internal forces. So if we consider these two blocks as one free body, then over here the external force, that is the force which the earth is applying, energy will never be internal force as far as the blocks etc that is concerned. And if we are not considering blocks and earth as one system, then mg is never going to be internal force. So over here 150 Newton is this way, 100 Newton is this way, so net force is 150 minus 100 is net force along the string. Net force is equal to mass, total mass, that is 20 plus 15 is 35 into A. So it is 50 is equal to 35 into A, and you get A is equal to 50 by 35 meter per second square. You get the same answer. Let's take one more case and see that is how fast we can get the answers. Let's say we have to find the acceleration of the blocks. In this case, we are just asked what is the acceleration like. So what we do is, that is whether we have such a system or its equivalent system is, if we combine these two together, if we combine these three together and we combine these two together, that's one and same thing. It will not alter the acceleration as far as acceleration is concerned. So this is 10 plus 10, 20 kg, and over here this is going to be 20 plus 10 plus 10, that is 50 kg is over here. So that is how it is going to be. So now the component of force, that is mg, this way is mg sin theta, that is 20 into g is this 10, sin 30 is half. So this comes out to be, that is 100 Newton is this way, and this way is m into g, 50 into g, that is 500 Newton. So the system like this is equivalent to system like this as far as the acceleration is concerned. So 500 Newton is, so if we take this as the whole body, so 500 Newton is being applied this way, 100 Newton is applied this way. So net force is 500 minus 100 is the resultant force along the string. 500 minus 100 Newton is responsible for accelerating all the masses. 20 kg here, 50 kg here. So it is 70 into A. 500 minus 400, that is 500 minus 100 is 400, divided by 70 is equal to A. 40 by 7 meter per second square is the acceleration. If you have to draw the force diagram for, let's say, for this block, if we talk about this block, and we have taken tensions like this in this T1, T2, and in this string we are taking it as T3, and in this string we are supposed taking it as T4. So equation for this, once again, where generally the students they make mistake is, equation for this will be, this will accelerate this way. So T3 minus T4. In addition to that, we are now just talking about the force diagram of this block. This method, when we use this, this gets us the value of acceleration faster. So over here, T3 is here, T4 is here. Have we taken into consideration all the forces? No, one force is missing. That is the component of mg in this direction, which is mg sin theta. That is mg sin theta. Mg sin theta component we have taken into consideration. M is what? 10. G is what? 10 into sin 30 is half. That is 50 Newton. So it is T3 minus T4 plus 50. These two forces, they are in this direction. This is net force is equal to mass 10 into acceleration. We can put the value from here 40 by 7 and we can get the answer. The other area where generally the students they make mistake is once again for this. If we draw the force diagram for this, it is going to be T2 is in this direction, T1 is in this direction. This is of 10 kg block we are talking about, and apart from this 100 Newton also it has to be taken into consideration. It is not just T2 and T1. So equation for this is 100 plus T1, this is accelerating down, so net force is downward, so downward forces minus upward forces. This downward force minus T2 is equal to mass of this block only, 10 into acceleration. Acceleration was 40 by 7. You can put the value and you can get the answer.